Okay, welcome back to section 3.5, part 2. Sorry about that. Let's go ahead and jump right in. So, Liu Wen takes 45 minutes to drive his boat upstream from the dock to his favorite fishing spot. It takes him 30 minutes to drive the boat back downstream to the dock. The boat's speed is going downstream is 4 miles per hour than its speed going upstream. So find the boat's upstream and downstream speeds. So here's the relevant information. So we have two situations. The boat's going upstream or downstream. Okay, so it takes 45 minutes, right? But the speed is in terms of miles per hour. So we need to convert 45 minutes to hours. So how we do that is we multiply by, the fraction 1 hour equivalent to 60 minutes. So basically you're multiplying by 1, but that changes the units to hours. So 45 over 60, which is 3/4 of an hour. So it takes him 3/4 of an hour to go upstream, and then 30 minutes, of course, is half an hour. But just in case you want to see the math, it's going to be, so 30 over 60, which of course is 1/2. Minutes cancel. So that's downstream, takes him half an hour. The boat speed going downstream is 4 miles per hour faster than the speed going upstream. We don't know what that is, so let's let that be our x, okay? So then to find the distance, we multiply across. So this becomes 3/4 x. This becomes 1/2 times the quantity x plus 4. Now here's the situation. Now, if he's going downstream and then back upstream, upstream or downstream, he's actually going the same distance, right? This isn't an add together to become a total situation. This is actually setting the distances equal to each other. So the equation that we can write here is 3/4 x is equal to 1/2 times the quantity x plus 4. So again, we can distribute the fraction 1/2 and simplify and do all that. Or we could multiply both sides by the LCD, which in this case is 4, and see how the fractions get eliminated, okay? Because I know you guys love fractions. Okay, so on the left-hand side, the 4s will cancel out and you get 3x. On the right-hand side, we have 1/2 times this quantity. So if I multiply by 4, 4 times 1/2 reduces to become 2 times x plus 4. See, now this is a lot nicer, right? Okay, so distributing, we get 3x is equal to 2x plus 8. So now we need to have the variables on the same side of the equation. So we subtract both sides by 2x. 3x minus 2x is just 1x today. And then we bring down the 8. So that means x is equal to 8. So the rate upstream is 8 miles per hour. 8 mph. But then downstream is 8 plus 4. Okay, so what's 8 plus 4? Well, that's 12 today. So 12 miles per hour, and that's it. Okay, let's try another one. Hamilton loves to travel to Las Vegas 250 miles from his home in Orange County. On his last trip, he left his house at 2 p.m. The first part of his trip was on congested city freeways. At 4 p.m., the traffic cleared and he was able to drive through the desert at a speed 1.75 times as fast as when he drove in the congested area. He arrived in Las Vegas at 6:30 p.m. Okay, so let's see here. How fast was he driving during each part of his trip? Okay, so he's going to Las Vegas. So if it helps to draw a picture, you draw a picture. Here he goes. This is Hamilton. He's starting here. He's going to Las Vegas. So he leaves at 2, and then he goes through this first part that's really crazy, and then at 4 p.m., so he drives so he leaves at 2 p.m., and then at 4 p.m. he gets here, and then here he goes a lot faster, okay? So And he ends up here at 6:30 p.m. Okay, so first we're going to talk about the congested part, meaning in traffic, when he's driving in traffic. And then we're going to talk about the non-traffic area or not congested part. Okay, so we don't know what the rate is, but it's asking here how fast. Well, in this part, he's going a certain rate, X. Okay, we're going to let that be X. But in the second part of the trip, he's going 1.75 times as fast. So that's going to be 1.75X. And then here we know how much time he drove because they give us time periods. So from his house to the end of the congested area is 2 hours. And so at this case, it's 4 p.m. And then from the end of the congested area to Las Vegas, it's 6:30. So that's 2.5 hours. So I'm going to write 2.5. Okay, and then we multiply across. So we get 2x here. And then we get 2.5 times 1.75x. Okay, we'll just leave that. And then, so what do? They're not equidistant to each other, but we forgot one piece of information. He lives in Orange County, so Las Vegas here, given to us, it's 255 miles away. So the total trip, if we add these two distances together, is going to be 255 miles, yeah? So let's go ahead and write that as a sentence. So 2x plus 2.5 times the quantity, 1.75x, is equal to 255. All right, so let's go ahead and multiply 2.5 by 1.75. And that becomes 4.375. So we have 2x plus 4.375x is equal to 255. So add them together. Plus 2, right? So that's going to be 6.375x equal to 255. And then to solve for x, we divide both sides by the coefficient of x. So then that's going to be what? 255 divided by 6.375, and that's going to give you 40. So he's going 40 miles per hour during the congested part. So during the congested part or in traffic, he's going 40 miles per hour. And then in non-traffic or not congested part, he's going 1.75 times 40. So let's see what that is. So times 1.75, that's going to be 70 miles per hour. And that's your solution right there. Okay, one more problem. So we have here, Cruz is training to compete in a triathlon. He left his house at 6 and ran till 7:30. So here we go. So he left his house. So let's say he left his house at 6 and he ran till 7:30. So 6 a.m. and then 7:30. Then he rode, so this is run. And then he rode his bike until 9:45. So then this is biking. And the total distance is 51 miles, okay? His speed when biking was 1.6 times his speed when running. So we don't know what that is, okay? And then find his biking and running speeds. Okay, so we have Cruz running and we have him biking, okay? It's a similar problem to the one we just did. So we don't know how fast he's running, so let that be X. But we do know that his speed when biking is 1.6 times his speed when running, okay? Oops, I was trying to be cool. Okay, then, so that's going to be 1.6x, you got it. Okay, so here it says he left his house at 6 and ran till 7:30, so he spent an hour and a half running. And then he rode his bike till 9:45, so he spent 2 hours and 15 minutes. But we need to convert 15 minutes to hours, okay? We already did that earlier because 30 minutes is equal to half, which is 0.5. Okay, so 1 hour, that's going to be 1/4, right? Because we know that 15 minutes is 1/4 of an hour anyway. So in decimals, that would be 0.25. So this is going to be 2.25 of an hour, 25 hundredths of an hour, which is, 1/4. Then we multiply across, okay, so 1.5x, and then we have 2.25 times 1.6x. And then what's the last piece that they gave us is that he ran a total of 51 miles. He covered total of 51. So we know that if we add the two distances, it has to be equal to 51. So let's go ahead and write that down. 1.5x plus 2.25 times 1.6x, or 1 6/10 x, is equal to 51. Okay, so basically you have to do the same calculation. You multiply 2.25 times 1.6, right? So then we get 1.5x plus, remember to write line by line. That way you do not lose any of your work, okay? So when you're solving a math equation, and I know I've said this probably a couple times by now, but make sure that when you do one calculation, write everything else down, nice and clear, line by line. Why do math instructors tell you to do this? Why? Well, I'll tell you why. The reason that we tell you to do this is that because when you go back to look at your work, you're not like, I don't know what I did. What happened? Why did I do that? If your work is all disorganized and all over the place, you're never going to be able to figure out where you need to grow and correct your own mistakes. But if you write line by line, nice and careful, you could very easily go back and see, oh, okay, I multiplied wrong, or, oh, okay, I added wrong. Oh, I forgot to do like terms. So that's why we tell you. It's not because we want to make your life difficult. Trust me. It's just easier for you in the long run. All right, rant over. Combine like terms, that becomes 5.1x is equal to 51. Divide both sides by 5.1. And we get x is equal to 10. So that was what? X represents the rate running. So running, he's going 10 miles per hour. And then biking, he's going 1.6 times 10. So that's going to be 16 miles per hour. All right. Okay, and that's it for this problem. And that's actually it for the section. So your super fun homework is section 3.5, the exercises 283 to 303 odd. So that's not that many problems, okay? So for those of you that are only doing the every other odds, I highly recommend you just do the odds in this case because, odds for 20 problems, that's not that many, okay? So good luck, and I will see you on the next video.